Assalamualaikum warahmatullahi wabarakatuh to our lecturer, Sir Muhammad Fauzi bin Mokhtar. So today our group is group number 4. We will present the case study of DCC 30093 Geotechnical Engineering about the laboratory undrained treasure shear test. Okay. Before that, I will introduce myself and our group members. My name is Muhammad Syamil Haikal bin Rumiano Kaswadi, and our group members is Melvin Anak Meling, Ahmad Sirajuddin bin Abdul Malik, and Eddie Ryan Anak Tommy. So, firstly, we will start with objective. To determine the shear strength parameter of soil, which are angle of internal friction and cohesion of soil with shape change of cohesive soils. Applicable standard DA2 D2 85003A standard test method for unconsolidated undrained terrestrial compression test on cohesive soils. Okay, for the purpose of measurement, undrained terrestrial shear test is one of the indirectly shear tests that carried out by imposing a cell pressure to the cylindrical shaped oil sample and then increasing the axial load, the resulting the shear failure that happen to the soil sample. When the test is conducted, maintain in the undrained conditions without allowing any pore water dissipation. At least 3 samples are needed. Make sure all samples will be imposed with different cell pressure and imposed by axial pressure until the entire sample is filled. From the value of axial pressure at the failure and cell pressure for every sample, more circle can be drawn and the value of cohesion and angle of internal friction can be determined. So, this is graph more circle. For the apparatus, number 1 is sampling tubes. Number 2 is rubber lining or membranes. Number 3 is membrane stretcher. Number 4 is rubber binder. And lastly, terrestrial cell or chamber. Okay, so for procedure. Procedure number 1 is 3 cylinder shaped soil samples measuring 76 mm long and 38 mm in diameter are prepared. Procedure number 2 is the sample are inserted into a rubber membrane and sealed on the top and bottom part using O-ring to prevent penetration of water into the samples. Procedure number 3 is a soil sample that is wrapped in rubber membrane is placed into the terrestrial cell. Make sure that the sample is standing upright and steady on the center of compression plate. Procedure number 4 is water is inserted into the terrestrial cell through intake valve until the whole cell is filled with water. An outlet valve is opened to release the trapped air. Procedure number 5 is all the valves on the terrestrial is closed and sample is imposed by 50 kN M2 of cell pressure. And then procedure number 6 is the reading on the deformation dial gauge are set to 0. The test is started with loading rate of 1.52 mm per minute. Axial load is added onto the sample until it fails. At the same time, the proving ring reading that represents the axial load is recorded. For every 20 multiplied by 0.01 mm standard dial reading that gives the value of vertical transparency. So, for the next procedure, I will pass to Eddie Ryan Anatomy.
Procedure number 7. Record gauge reading every 0, 20, 40, 60, 80 and so on until one of the following instances occur. Reduction of load gauge is clearly seen. Next, tree reading of load gauge is constant. And shift more than 20% strain. Procedure number 8. The form of the failed soil sample is sketched, and moisture content for every tested sample is determined. The same procedure is repeated for other samples. For cell pressure 100 kN per meter square and 200 kN per meter square. The used proving ring number is not, and calibration data is obtained. Finally, stress and strain calculated for each reading. A graph of stress versus strain is plotted, and maximum shear strain of each sample is shown. More circle is drawn to determine cohesion and friction angle. As you can see, there are three types of failure for the soil sample. First, general shear failure. Second, local shear failure. Lastly, punching shear failure.
Hello everyone, so my name is Melvin Anamaling. So to find the data at this table, you have to first go to the part here where you take 20 times 0.01 equal to 0.2 and repeat until you get all the part of data here. Then following gauge, you have to take the part here, load time part is the formula, so 2 times 0.0167 you will get 0.0334. Then we need to find a, that is a original area times length divided by length minus part. Then repeat that until you get all the answer for it. Then for the normal stress, you have to get P divided by A, that is 0.0334 divided by 0.0137, you will get 29.38. For the strain, take the 0.2 divided by 0.76, you will get 2.63. Then divided by 1000, cause change the unit and round up the number and you will get 0.03, and repeat the whole process for the rest data, same to with data table 2 and table 3. So as you can see here, this is our graph, the stress versus strain graph. As you can see here, there are data 1, data 2, data 3. For the data 1 is about to be the lower, and for data 2 is in the middle, is kind of medium type of height, and data 3 is the highest height, the highest point or graph all over that among the data 2 and 1. Then the next question is to plot more circle and find shear strength of soil. First, take the highest point on the three data that we get on the stress versus strain graph, then plus with the cell pressure, you will get the major stress. To find the major stress is first take a cell pressure that is 50 plus with normal stress that is 284, and it will equal to 334. As you can see, this is our morph cycle graph. Then if you can see, for the friction of soil, the point is 33 degree, and for the coefficient is 50 degree. Let me explain to you how to find the shear strength. So the first point is 50, that is a coefficient, then plus with normal stress, that is 284, ton with the friction of soil, that is 33, and you will get 234.43 kilonewton meter per cube second. And keep repeat this whole process until you get 3 sample for the shear strength.
So hello, my name is Ahmad Shaduddin bin Abdul Malik, and today I will explain about the advantage of this test compared to other tested in finding the soil strength. So trivial tests are one of the most widely performed tests in geotechnical laboratory. The advantages of the test over other test methods used in the geotechnical laboratory used to determine shear strength, such as direct shear, is that specimen drainage can be controlled and pore pressure can be measured. Okay, so the first one is the stress distribution on the failure plane is uniform. Next, the specimen is free to fail on the weakest plane. Number 3, there is complete control over the drainage. Number 4, pore pressure changes and the volumetric changes can be measured directly. Number 5, the state of stress at all intermediate stages up to failure is known. The more circle can be drawn at any stage of shear. This test is suitable for accurate research work and the apparatus adaptable to special requirements such as extension tests and tests for different stress paths. So for next is, as you can see in the diagram here, cohesive C refer lab sheet data. So in the data we get that C is 50 and friction of soil is 33. Okay, so as you can see in this table, for the DEG 33, the NC that you will get is 48.09, for NQ is 32.23, and for the NA is 31.94. This is the calculation. So C is 50 kilonewton over meter square, friction of the soil is 33, Q is 300 kilonewton, Z is 1.5 meter, Y is 18 kilonewton over meter cube, safety factor is 2.5, and B is unknown. So friction of the soil 33 equal to NC 4809, NQ 32.23, and Y is 31.94. So to find the ultimate bearing capacity, the formula is QF equal to 1.3 N plus YZ NQ plus 0.4 YB and Y. So QF equal to 1.3 times 50 times 48.90 plus 18 times 1.5 times 32.23 plus 0.4 times 18 times B times 31.94. So QF is equal to 3996.06 plus 229.97B. So for next is no ultimate bearing capacity. So QF N equal to QF minus PO equal to QF minus YZ times YZW. So QFN is equal to 3996.06 plus 229.97B minus 18 times 1.5 times 0. So QFN is equal to 3969.06 plus 229.97B. So the design loads is Q over B times B minus PO equal to 300 kilonewton over B square minus 18 times 1.5 times 0. So Q over B times B minus O equal to 300 kilonewton over B2 minus 7. So next is to find tooting B. B equal to A over BXB minus PO equal to QF over F5. So B equal to 300 minus B2 minus 27 equal to 3696.06 plus 229.97B over 2.5. So B is equal to 750 minus 27B2 equal to 3696.06B2 plus 229.97B3. So B equal to 229.97B3 plus 399.6.06B2 minus 750 equal to 0. So B is equal to 0.4. This is our references. So that's all from us. Thank you very much.